Hello everyone, my name is Esimran Aymiroğlu and I'm a second year computer science student here at Bilkent University. And today I will be presenting you my Physics 101 project, which is investigating the factors that affect an object's final velocity when released from an inclined plane. The main objective of this experiment is not to show the conservation of energy because there's friction, but even if there's friction inside the system, the mass of the object does not affect the final velocity, but the release height does. And the relationship between v and the square root of h is directly proportional. This is my main objective that I want to show in my video. Enjoy watching. I will use an inclined plane, an air table, and a ruler to measure the height. In the first part of the experiment, I dropped the mass from 5 different heights. In the second part of the experiment, I changed the mass and dropped it from 5 different heights again. I did the same thing for 4 different masses. After collecting the data, I measured the distance between 2 data points to find the final velocity of the object. After calculating the final velocity of the object, after each drop, I recorded these into a table. I calculated the theoretical value from the equation mgh is equal to 1 over 2 mv squared to compare the values of experimental values and theoretical values for error calculations. As you can see, experimental values for m and for m are pretty close in every height. I dropped 4 different masses from the same height, which is the second lowest height, and recorded their velocity values into a table. As you can see, the values are pretty close to each other because the mass of the object does not affect the final velocity of the object. I turned these values into 2 graphs, which one for the first part of the experiment and the other one for the second part of the experiment. As you can see from the graph named different masses, the graph is linear. This means the object velocity didn't change when we changed its mass. However, in the second graph, we can see that the values for velocity of the object changed when we changed the release height of the object. And we can see that the line for m and for m are nearly the same lines. However, these two lines are less than the theoretical values because of the energy loss. However, the 3 lines still behave the same way, which is pretty close to the graph of the square root of x. As a conclusion, we can see that even if the system is frictionless or we have friction inside the system, the mass of the object does not affect the final velocity of the object. However, the release height affects the final velocity of the object. And as we can see from the graph of h and v, we can see that the graph is pretty similar to the graph of the square root of x, because even if we have friction in the system or the system is frictionless, v is directly proportional to the square root of 2gh. So that's it from my experiment, and thank you for listening.